There is a planet in our solar system that does not belong here. It was not born here. It did not form from the same cloud of gas and dust that built Earth, Jupiter, or Saturn. It came from somewhere else entirely, another star, another system, another corner of the galaxy. And somehow, against all astronomical odds, our sun reached out across the darkness and never let it go. This is not science fiction. This is where the data is pointing. To understand how something like this is even possible, you have to first understand just how crowded and violent the early galaxy truly was. When our solar system was forming, roughly 4.6 billion years ago, the sun was not the lonely middle-aged star it is today. It was a newborn, embedded inside a dense stellar nursery, a massive cloud of gas and dust packed with hundreds, possibly thousands of other young stars forming all at once, shoulder to shoulder on a cosmic scale. This is called an open star cluster, and in that environment, stars were close, not just close by galactic standards, genuinely, meaningfully close. Close enough that their gravitational fields overlapped. Close enough that what happened to one star's planetary system could directly affect its neighbors. And in that chaos, planets were getting thrown out constantly. Every time a young solar system forms, it is an act of violence. Gas giants migrate. Planets jostle for orbital real estate. Gravitational slingshots fling smaller worlds inward and outward with brutal efficiency. Scientists estimate that for every planet that survived and settled into a stable orbit, several more were ejected entirely, launched into the cold interstellar void, unbound from their home star, and left to drift silently through the galaxy for billions of years. The Milky Way, by some estimates, may contain more rogue planets than stars. We are talking about hundreds of billions of free-floating worlds wandering in the dark. Invisible, orphaned, adrift. Now, here is where it gets extraordinary. When two stars in that ancient nursery passed close enough to each other, their gravitational fields didn't just wave politely and move on. They interacted. They tugged on each other's planets, their comets, their debris. And in rare but statistically plausible cases, one star could capture a planet from another. A rogue world, or even a planet still loosely bound to a neighboring star, could get gravitationally snagged by the passing sun, pulled into a new orbit, and permanently adopted. It would not announce itself. There would be no flash of light, no explosion. It would simply begin to orbit, quietly, in the outermost reaches of a system that was never its home. The question scientists are now seriously asking is this: did our sun do exactly that? For years, astronomers noticed something deeply unsettling about the Oort cloud. The Oort cloud is the vast spherical shell of icy bodies that surrounds the solar system at distances of up to 100,000 astronomical units. It is the sun's gravitational kingdom at its most extreme edge, a frozen archive of the solar system's earliest history. But when scientists mapped the orbital orientations of long-period comets, the ones that originate from the Oort cloud and swing through the inner solar system on journeys lasting millions of years, they found that some of them had orbital inclinations that seemed almost impossible to explain using only the sun's own planetary architecture. Their trajectories were too tilted, too scattered. Something with a very specific gravitational signature had disturbed the Oort cloud from the inside, reaching in and stirring the icy debris into configurations that the known planets simply cannot account for. That fingerprint points to a hidden world. But the nature of that world, that is where it gets genuinely staggering. In 2021, a team of researchers published a detailed dynamical study that pushed the boundaries of what we consider possible. Using gravitational simulations of the early solar system embedded inside a stellar cluster, They found that the probability of the Sun capturing a rogue planet during its nursery phase was not negligibly small. It was, in fact, surprisingly plausible. Depending on the density of the cluster and the duration of time the Sun spent embedded within it, the capture probability for a Neptune-sized or super-Earth-sized world reached values that could not be casually dismissed. The math didn't say it was certain, but it said it was entirely within reason. And in science, entirely within reason combined with unexplained observational evidence is where discoveries are made. Now, the most compelling candidate for a captured world in our own solar system has a name you have likely heard before: Planet 9. But what most people don't realize is that while the existence of Planet 9 was originally proposed to explain the clustering of Kuiper Belt objects, the captured rogue planet hypothesis offers a completely independent and startlingly elegant explanation for why Planet 9's orbit looks the way it does, if it exists. A planet born inside our solar system would have formed in the flat plane of the solar nebula. Its orbit would be relatively aligned with the other planets, give or take some gravitational jostling over time. But the orbital parameters astronomers have reverse-engineered from the clustering of distant Kuiper Belt objects point to something with an extremely elongated, highly inclined orbit. An orbit that is wildly out of step with the neat, flat architecture of the rest of the solar system. An orbit that looks less like something born here and more like something that arrived here from somewhere else and never quite settled in. A captured rogue planet wouldn't share the angular momentum of our solar system's formation disk. It would carry the imprint of its own violent origin story, a strange, tilted, elliptical path that would forever set it apart from the native planets. That is exactly what the data suggests Planet 9's orbit looks like. There is another piece of evidence that makes this hypothesis even more difficult to ignore. In 2020, astronomers studying the trans-Neptunian region found a peculiar object designated 2015 BP519, nicknamed Kaju. This object has an orbital inclination of roughly 54 degrees, nearly perpendicular to the solar system's flat plane. Nothing in the standard model of solar system formation can explain that inclination on its own. When scientists ran simulations including a distant massive planet on a highly inclined orbit, the existence of Kaju suddenly made complete sense. The inclined intruder was gravitationally scattering these objects into bizarre orientations over billions of years, leaving them as breadcrumbs pointing back to something that should not be there, something that was not born here. And consider the implications of what that means for the Oort cloud itself. The Oort cloud is thought to have been built up over time as Neptune and the other giant planets scattered billions of icy planetesimals outward during the chaotic early solar system. But some researchers have found that certain populations within the Oort cloud have properties that suggest an external origin, not material scattered outward by our own planets, but material that was gravitationally swept in from outside. If a captured planet arrived with its own cloud of debris, its own retinue of icy objects loosely bound to it from its former star system, the Sun's gravity could have gradually stripped those objects away and incorporated them into the outer Oort cloud. We might be looking at fossilized remnants of another star's planetary system, scattered through the edges of our own, and we wouldn't even know it. This is the part where the sheer scale of the concept starts to settle in, and it is genuinely difficult to sit with. Think about what a rogue planet's history would look like from a geological perspective. It was born orbiting some star we will never identify, in a solar system that may no longer exist. It was violently ejected, likely by a gravitational encounter with a gas giant in its home system, and then it spent an unknown amount of time, possibly hundreds of millions of years, wandering through interstellar space, in absolute zero darkness. No star to warm it, no light to illuminate it, just an endless frozen drift through the void between the stars. And then, against all odds, it encountered our sun. Slowly, over an immense span of time, the sun's gravity began to curve its path. The rogue world arced inward, decelerated relative to its incoming trajectory, and settled into a vast, looping orbit around a star that was never its own. It became ours without ever belonging to us. Detecting it is the central challenge of our era in planetary astronomy. At distances of 400 to 800 astronomical units, this hypothetical world receives almost no sunlight. It is cold beyond comprehension, its surface temperature barely above absolute zero. Whatever atmosphere it may have once possessed froze solid billions of years ago and collapsed to the ground. And if it is a captured super-Earth or Neptune-class world, it might be dark, its outer layers composed of complex organic molecules and methane ices that absorb light rather than reflect it. From Earth, it would appear as nothing more than an extraordinarily faint, slow-moving point of light, distinguishable from background stars only by its gradual crawl across the sky over months and years of observation. But the tools to find it are finally coming online. The Vera Rubin Observatory in the Chilean Andes, which achieved first light in June 2025 and began its legacy survey of space and time in early 2026, is built precisely for this kind of search. Its 8.4-meter mirror paired with a 3,200-megapixel camera will image the entire visible southern sky every few nights for a decade, building up a time-lapse record of the sky so detailed that a slow-moving outer solar system object would stand out like a single pixel blinking against a static background. If Planet 9, or whatever we eventually name this captured intruder, lies within the survey footprint, Vera Rubin will find it. And when that detection comes, the confirmation will not just be a planetary discovery. It will be a moment of profound, almost philosophical consequence. Because here is what it really means. If our sun captured a rogue planet, then the solar system you learned about in school, the tidy model with 8 planets all born from the same cloud, all family, is incomplete. There is a 9th world out there with a completely different origin story. It came from the dark. It came from somewhere we cannot trace, born around a star we cannot name, and it has been silently orbiting our sun for potentially billions of years. It has been here through every mass extinction, through the rise of the dinosaurs and their fall, through the entire history of human civilization, and we never knew it existed. The galaxy is not a collection of isolated, independent solar systems. It is a living, interacting web of gravitational relationships. Stars pass near each other. Planets are exchanged. Material from one system seeds another. What we call our solar system may be partially, quietly the solar system of another star entirely. And if it happened to us, it happened to others. The exoplanet systems we are mapping across the galaxy may each harbor their own silent intruders, captured worlds orbiting in the cold, dark margins, carrying the geological and chemical records of stars and civilizations we may never find. We have been asking the question of whether we are alone in the universe for as long as we have been looking up. But maybe the more unsettling question is this: in what sense is the solar system even ours? The boundary between our solar system and the rest of the galaxy may be far more porous, far more ancient, and far more interconnected than we ever imagined. And somewhere out in the deep dark, a frozen world that was born around another star is still orbiting our sun, waiting to be found, carrying a story that began before our own sun was born. When we finally find it, we will not just be discovering a new planet. We will be reading the first page of a story that began in another solar system, billions of years ago. And that should make every single one of us stop, look up, and feel the full, staggering weight of how small and interconnected this universe truly is. What do you think? If Planet 9 turns out to be a captured rogue world from another star, does that change how you see the solar system? Does it change how you see home? Drop your thoughts in the comments below, because this conversation deserves to be had. If this video left you thinking, share it with someone who still believes the solar system is a simple, settled place. And subscribe, because the universe is not done surprising us, and neither are we.